Hello, everybody. Can you all hear me? Great. Can someone talk so I can make sure my audio is working?
Can you hear me, Tyler?
Yep, gotcha.
Awesome.
Okie dokie. Well, let me. What is that shiny? Oh, it's that light. I'll do this. Nope. Okay. All right, guys, we'll give people a couple minutes to show up, and then we'll get going. We're going to talk a lot about the post-class practice from last time. So if you pull up Fusion and pull up that file, if you've got access to it or something so that you can reference, we'll be chatting about that a little bit more. Hi, Ashley.
Hey Tyler, just a heads up. I've been playing catch up a little bit with this, so I have not done much on that post.
That's okay.
So
That is a-okay. We'll talk about it pretty in depth right now. And then we'll go from there. Audio settings, there we go. It always puts my headphone volume at an insane high amount. So everybody's just super loud to me. Okay, great. But that's okay, Ashley. We'll go over it in depth. We'll talk about the things we learned. And if you do it after this, you'll probably get the same stuff from it. So don't worry about it. Well, hello, Benjamin. How's it going? Oh, good. Okay, I think this might be everyone who's going to end up coming.
Oh, here we go.
Luke Gardner probably isn't aware of the new time because he never checks Slack. So we'll just get going then. Okay, guys, so I've been thinking about how to structure the class a little bit differently. And what we're going to do is we're going to kind of primarily focus on those post-class assignments. I'm going to spend a little bit more time and make those in-depth like they were last time. Kind of more exercises to go through to expose you to more things. Obviously, me talking to you guys is not the best way to get all of the exposure. So you guys are aware, one of the hardest things about this class is that we can't actually, it's harder for us to get you guys to actually cam things and actually run them on machines. So we're kind of focusing a little bit more on the button clicking side of things than the numbers and values side of things. So if it's a little slight on values and numbers, it's totally deliberate. But feel free to ask any questions still in that. So how many of you were able to do the post-class assignment, do the contours practice that I put up? Were any of you able to get to that? You got it, Johnny?
Yeah, I was able to do it.
No? Okay. What about you, Luke?
I didn't go to last class, so
Okay.
but
That's totally cool.
I've been doing some contours, just not your contour practice.
That's okay. So we'll go through it then, and we'll talk about some of the things that each one will have you learn. And then we'll talk over 2D adaptives, and then we'll probably end a little early today. Trying to get these a little bit shorter, give you more afterwards and less during. Okay, well, let's pull up what I had you guys do for post-class practice. Okay, so this is what I gave you guys to work with. So you each have a copy of that model that you were able to work with, and you're supposed to go through and select all the contours that I showed in here, I hope that it's visible which part of which contour you're supposed to practice with. But maybe we'll go through and we'll just kind of hit some of the main points together so that when you guys actually go through and do it, you'll get a little bit more exposure to some of those key principles. Okay, so the interesting ones here, we're just gonna go, instead of going through the entire assignment, first we'll just ask, Johnny, do you have any questions about any of the specific exercises?
I can't think of any questions right now, but I
That's okay.
the problems.
Uh-huh.
Probably like the main thing, for example, was like I went to go do the contours, and it just had a ton of interference because I had to take down the material first.
Okay.
And so, yeah, that was like pretty much the biggest thing once I figured out.
The simulation doesn't work too well for this exercise because we weren't actually roughing anything out. So that's what we're going to learn how to do today. This one was more about seeing the tool paths, less about simulating them, but we'll get into simulations today.
Okay, sweet.
So we're going to go through this. I've got it pulled up here in my Fusion window, and we'll talk about some stuff. Also, my computer, I forgot my charging cable at home. So that's another reason today's going to have to be a little shorter. My computer's probably going to die as soon as we start doing a ton of Fusion stuff. But we'll get through what we need to today. So the specific contours that I asked you guys to go through and select was this bottom one that runs along that guy, bottom here, bottom there, top along this one, which is a multi-line contour, and then bottom here to get you practice with ramps. We're going to look at a couple other cases just to talk in depth about 2D contours, less about the stuff that pops up in that window and more about the stuff that, sorry, I'm hiding you guys from my view. Less about the stuff that pops up in here and more about the stuff that we're going to select in here. That's one of the hardest things about Fusion is selections get a little janky. We're going to see that especially with the 2D adaptive today. So we'll go over specific selection stuff in contours and then move on. I'm going to come in, I'm going to select just our 1/4 inch flat. You can use any of these same principles apply with any of the tools. So you see by default when I'm selecting contours, Fusion's trying its best to guess the closed or open loop that I'm going for. It knows what plane I'm working in because I've specified it in my stock setup. So it knows Z is up. So it knows a 2D contour is going to be looking for contours this way, not contours in a 3-dimensional system. So it tries its best to guess. And if I just click, it'll select the entirety of the contour I'm looking at. One of the biggest tools for letting us change that is to re-click the contour and bring up this dialog box. So this allows us to select a closed contour versus an open contour. Who knows the difference between, there. Who knows the difference between a closed contour and an open contour? Who wants to take a guess at that? So what would be the difference, do you think, between a closed contour and an open contour? Anyone willing to venture a guess? Great, I'll just show you. So an open contour is a contour like this one. So you see how that contour, as it follows around, doesn't complete a full loop? Whereas when I go to select this contour, it completes a full loop. That's a closed contour, and that's an open contour. That selection box lets us change between which we're doing. So if I want to click closed contour, it'll do its best guess as to, okay, he probably wants to mill along this entire contour. In this case, that would do weird things that we don't want it to. But what I can do is feed it different inputs. Let's say I wanted to come actually along here. As I start clicking lines, it will update the contour to include those lines. So see how I clicked that vertical line and now it's following the contour along here. I can come in and click other lines. So if I come in and click this one, all of a sudden now it's doing some super weird wonky contour that runs all the way down and back. Fusion does its best to guess. It's not the most intelligent. But I'm going to come in and select again. So let's say I was selecting this contour, but all I wanted to get was this part right here, none of this extra side. So I come in to select a closed, an open contour, and I select that as my endpoint, and I deselect this back here. So I'm holding the control button and I click that. It gets rid of that selection. You can see my selections are in blue, and my the Fusion's guess is in black. That is one thing that you'll play around with more in the practice for this time, so be aware of that. Also, if I just hit escape or move out, this contour won't be saved. If I go back, oh, whoops, it deleted my entire operation. But in order to save that contour selection, I have to go in, open that dialog box by clicking again, selecting my open contour, selecting that guy, deselecting that one. And then I have to click this plus button to accept the current contour. Now Fusion knows I want to mill along that guy. So as I've selected this top edge, we're going to see something weird happen. And I'm not going to change any of the default parameters. They're all going to stay the same. So this line right here is where the dead center of the tip of the tool is following. So in the case of this 1/4 inch end mill, it's the tip of that tool. So if I were to cut along this, and let's say the part actually looked like this, it's not actually going to really be cutting anything. The edge of that tool is going to be running right along this edge that I'd selected here. If I want to change the depth of that contour, I have to come into the heights tab, and I have to change the bottom height of my contour. Currently, it's as my selected contour, but I want to change that to a selection that I make here. Notice it opens up this bottom reference selection right here. Anytime you see your mouse in a blue box, that means you're supposed to be telling Fusion what you want. So I can come in, I can select a point, or I can select a face. In this case, I'll select that face. And you'll notice this blue bottom plane jumps down to where that is. And then the number associated with it on this guy right here is relative to our stock 0. So what this is saying is this plane is 1.379 inches below where my stock origin is. But if I come into here, nowhere does that number actually appear, because this offset right here is relative to my selection. Let's say I wanted to go 0.25 inches lower than my selection. I punch in minus 0.25. You notice this blue plane is now 1/4 inch below that selection. In Mastercam, that's called absolute versus incremental. So this is what's called an incremental selection mode. It's one of the things that messes us up in Mastercam, but it's the default in Fusion, and there's not really many ways to change that. If I select OK now, you'll see my toolpath update, and my tool is actually going to plunge into my part and mill 0.25 inches below that plane along that contour we'd selected. I'm going to go over one other selection thing real quick. That's pretty important. So you'll notice I've selected my contour here, and it highlights that in bright blue. There's also this arrow floating right here. What that is that's the offset of your tool. So that means the center of my tool is going to be on the same side that this arrow is. Let's say for some reason I wanted to cut into the part as opposed to cutting outside this contour. If I click that, you see the arrow changes side, and we're going to see what the toolpath actually does. So we can't see the blue toolpath, but you see the tool is offsetting to the other side of this line. That's critical in some situations, but it can mess you up in others. So that's something to be aware of. But we'll see that arrow very frequently. And by clicking it, you change which side your tool goes on. Okay, those are some of the main things that you get out of this practice. Changing which selections you're going along. Another thing you're going to play with is something called the tangential extend distance. So I'm going to punch my stuff back to where it should be. Okay. So you see as we come in here, my toolpath, oh, whoops. Where are you, toolpath? There we are. My toolpath, let's pretend my tool follows along this path. It's going to successfully nail that edge and follow all the way along all these edges until it comes to here. So now we're seeing this toolpath right here is stopping right when the edge of the tool mills this point, and then it comes out and moves away. In this case, that's a little bit of a problem. We want it to mill along this edge, so we need to select a little bit more. We come into our edit toolpath again, play with our geometry. We come in and click this toolpath to open up this window again, and then we can add on this part. Once again, because we've selected open contour, Fusion's guessing something really dumb. It's guessing that I want to go all the way along this outside again. So we need to find the blue section that it's selecting. Oh, okay, that's what it's doing. So now instead of following this edge, Fusion's following this outside edge, which we don't want. So we just come in, we select another face along here, and we just keep selecting faces until Fusion figures its dang thing out. Okay, in that case, it didn't work. So we're gonna come in and try something else again. We're gonna select a face in here, and then we're gonna select this guy out here. What that does is it lets Fusion know, hey, you're on the right track. Make sure to keep this in your calculation, and then I'm going to put this on the end. I'm not exactly sure why that happened. So interesting. Sometimes you have to play around with different selection orders in Fusion. So now we can see we've got that along there. But when I come in and do my toolpath, we'll see the tool still stops right along that edge right there and then pulls away. Let's say I want it to go a little bit farther than that edge, which is generally a good idea in machining. We come in, and we're going to play around with something on our geometry tab. Oh, not tabs. We're going to come in, and we're going to edit this tangential extend distance box. If you go in and look at it, it'll explain what I'm about to explain to you. But what this allows us to do, let's say I punch in a 1/4 inch. We're going to see what that does to our toolpath. So instead of starting right here, it starts a 1/4 inch in a straight line of motion away from that point. It ends a 1/4 inch in a straight line away from the point where it ended before. That parameter is really useful for making sure there are no cusps on your part. Generally, anytime you have an open contour like this, you'll use that tangential extend distance. Okay, one other thing the practice is gonna have you do is a ramped contour. I'm gonna make a new one. Hey, Jennifer, we've got someone up front. How's it going? Jennifer, we'll be right here. All right, so something else that we play with is under this linking tab. So let's, same tool, and I'm gonna select this contour right here. One other option we play with is this ramp option. So we'll look at it without the ramp first, and then we'll look at it with the ramp. So if I do not select a ramp here, You see my tool comes in, it goes down to this plane right here of my selection, and then goes around this oval. Let's say I don't want it to do that. I want it to cut a little bit at a time. I come in to ramp my contour. So now we're going to take a look at what it does. Instead of plunging straight down and following that contour once, this guy will follow that in a little spiral. And it'll gradually make its way down. This is a really useful toolpath for cutting down into things, and it's used very, very commonly in the CNC router world. When you do the post-class practice, make sure to play around with that one. Okay, one other thing I'll teach you with selection. So before I showed you, you can select 3D geometry. So I can come in and I can select this. I selected that edge, but if you look, it's taking the projection of that edge onto the lowest point of the curve. That's one thing to be aware of with 2D contours, is they will not follow a three-dimensional surface. So beware of that. Okay, I think you guys, you'll get a lot from doing that post-class practice and playing around with different options. You'll learn more than I can teach you right here. Okay, any questions on all of that stuff as it stands right now? I just threw a lot of random stuff at you. Okay, great. Well, then we'll go on and I'll give you a very basic introduction to 2D adaptive clearing, and then I will release you guys, and hopefully you can take some of this time that we would have been in this class to go through and do that post-class practice for the 2D contour. So for the 2D adaptive clearing. Oh yeah, go for it.
This old Tony, he has a second part to the video you sent out earlier, and it's actually pretty good. He goes through
oh, awesome.
Just a really simple one. So I think
cool.
that could be helpful for some people.
Awesome. I'll send that one out after this class. Okay. Thanks, Ashley. Okay, so we're going to go into 2D adaptive clearing. So you'll notice, as with every Fusion toolpath, we have these same 5 tabs: tool, geometry, heights, passes, and linking. Same boxes that we put all our stuff in, but you notice there's different options. It selected my default
Tyler,
tool.
I have a quick question. Now that you mentioned it about like picking your tools, like I don't have enough experience to like know exactly which tools are right for the job. So is there like a generic tool that I could use just for like getting the processes down before I actually start figuring out like which tools are right for the job? Like, is there a generic tool that I could use?
So in the post-class practices, I'll just tell you to use a 1/4 inch or a 1/2 inch or a 3/8 inch straight end mill. Fusion doesn't care whether it's spiral or straight fluted, so you don't have to care either. Basically, the most basic tool you can use is a flat end mill. Various sizes of this cylinder right here. Pretty much every toolpath we're going to use, we'll use that same tool just as the default. We're going to have one discussion later on different types of tools where we'll talk about chamfer mills and various different bits and stuff that have different geometries. But yeah, Benjamin, for everything now, just use a straight end mill. Whether it's 1/2 inch, 1/4 inch, 3/8, go for it. Good question, Ben. Okay. So once again, I'm using that generic tool. I'm just using the generic 1/4 inch. I'm not touching any of these values because you'll do those once you start playing with the actual machine. So now in our geometry selection, a 2D adaptive gets a little bit different. For a 2D contour, all Fusion wanted to know is what contour we wanted to mill on. Now we've got a bunch of other options. You notice it's letting me select a face or a contour. So we're going to look at the difference between those two. So I'm going to start by selecting a face. So we're going to look at this closed pocket first, and then we'll look at this open pocket. I'll show you first off that you can select multiples of anything. So in this same toolpath, I can select multiple things, and they'll all show me different stuff. As I go through and generate those, it'll give me toolpaths according to each selection. That gets really powerful once you learn what Fusion expects and what it'll give you for different things. But for now, I'd recommend doing one selection per toolpath until you're more familiar with what all the parameters are and what it's going to do. Okay. Yeah, don't do that. That'll take forever. So we're going to come in, I'm going to clear all these selections. We're just going to select the bottom of this pocket, and we're going to select the top of this pocket, and then we're going to see what the difference is between the two. Okay, so it's going to generate, and we're just looking at the defaults, just kind of giving an overview of what each part is, what each part of this toolpath is, and what we're going to want to have control over. So colors of these toolpaths, you see red is anything that's a lead-in that's expected to cut stuff. So this red means the tool is plunging down in this helix, and it's going to cut stuff. Anything yellow is a retract or a backfeed move. So the machine's going to move really fast, and it's not expecting to touch anything. Green is the same way, except they're arc-shaped as opposed to straight. And all of that gives us a little bit of context for what it's doing here. So we're just going to watch the tool as it goes through and does this. And I'm going to speed it up a little. Okay, so you see the tool helixes down into that pocket and then starts spreading out like this. We'll actually look at what that looks like in a pocket in simulation later. But you see with an adaptive toolpath, eventually it'll get into a corner. There we go, and it'll start focusing on one spot as opposed to in a full circle. There we go. So you see it's focusing on this one area, and that's where all those yellow lines come in. Those are called backfeed, and that's the machine just hopping back before it cuts something else. We'll talk a little bit more about that. Then you look for this one, we selected the contour, and it basically did the same thing it did on this guy, except at the level that that contour selection was. So be aware of that. You can select this contour as well. Another thing with that contour is, as we come in to edit these, notice that arrow again. When we click that arrow, you notice the blue changes to the outside, but the contour stays the same. The blue is what this guy is expecting to machine. So if I come in and let that generate, it's going to come in and it's going to blanket this entire piece of craziness with a toolpath. Because I've told it to mill everything outside of that contour. So you can see selecting contours versus faces makes very different stuff. We're going to see another example of that right here. So this is an open pocket. If I were machining this, I would want my tool to come from the outside. I want it to have nothing here when I'm done. But we're going to see if I just select this face, Fusion doesn't figure that out. I'm going to change one thing real quick. This is an example of using that edit expression. I'll talk to you a little bit more about that in a minute. But when I come in and generate this, I selected that. What? Wow, you figured it out this time, you weirdo. Okay, well, what I was expecting it to do and what it did earlier for me, and I don't know why it didn't do it now, is, oh no, that's why. Ha, okay, I selected the wrong thing. Instead of looking at selecting a face first, we're gonna look at selecting a contour. So let's say I wanna make a closed contour right there. I select this, but Fusion picks the wrong spot. I want to come in, select closed contour, and include that edge. And now you see it's got the full closed contour there. I'm going to flip that arrow so it's machining the inside of this. If you look, it's not going to do exactly what we want. Instead of approaching this from the outside, it doesn't know what's supposed to be out here. It doesn't know that there's air over here. It thinks, because we've selected a contour, that it's another enclosed pocket like this. So it pretends like we want a wall right there. And that's not the behavior we want. There are things I can change to make that contour selection work. But now watch what happens when I select that face as opposed to that contour. Should generate here in a minute. There we go. So now, instead of going down in the middle and pretending like there's a solid wall on the outside here, because we've selected a pocket, Fusion knows, oh, hey, I see there's no wall over here. I can bring my tool in from the side and be a little bit more efficient with how this machining goes. That's something you guys are going to play around with in the post-class practice. And it's one of the big things that makes a difference in Fusion versus Mastercam. You can get a lot of different behaviors with different things. Okay, any questions about geometry selection so far? Okay, great. You guys will get a lot more answers as you do post-class practice that I'll probably post in the next day or two. I'm going to run you through some of these other options real quick just to familiarize you where they are. But you're going to, once again, work those in the post-class practice. Stock contours, what that allows us to do is that allows us to tell our machine, hey, our stock is actually a different size than I told you before. This is actually the shape of my stock right here. It does some interesting stuff, and we'll play with it a little. Rest machining. We'll talk a little bit more about the difference between 2D rest machining and 3D rest machining in Fusion. But the general goal is saying, hey, I came in with a 1/2" tool already and got everything I thought I could. Just go in and get the stuff that I couldn't have gotten with a 1/2" tool. So it goes, okay, cool. This pocket right here was too wide for your 1/2" tool. I'll do that. This corner in here was too big for your 1/2" tool. I'll go do that. But I'm not going to spend time machining the air that you already, of the material you already got rid of with that 1/2" tool. But once again, we'll have an entire dedicated time talking to rest machining in Fusion because it's very different. Those options you don't really play with, you can learn about them yourselves. Heights work the same way as they did in the 2D contour. But now we end up getting some different parameters in here. We get a tolerance, which basically tells us, tells Fusion how much do we care about sticking exactly to that contour. Can you leave little bumps and bruises along the edge, or do I want to just go quick and dirty and get everything as fast as possible, or do I want to make contours really smooth? Optimal load is a very interesting one, and it's the one you'll probably play with the most. So you remember, we're actually going to watch this tool machine for a minute, and we're going to see what it does. So actually, I'm going to edit something real quick. I'm going to give us a longer tool so we can see exactly what it does. So I'm going to come in and I'm going to edit my tool. What? Why can't I edit that tool? Well, fine then. I'll throw in a 1/2" end mill, and we're going to edit that tool. Ah, there we go. Now we can edit them. We'll use the 1/4" and we'll edit it. I'm going to come in and just make the tool length the flute length longer so we can actually see what's going on here. And you don't want me to save that for some reason, and that's really dumb. I think it thinks I did something wrong. There we go. that better? Okay. I had invalid geometry. I was saying the flute length was longer than all these other pieces that should be longer than the flute length. Make sure those are good before you do stuff. Okay. So because I've changed that tool, all of these operations are now invalid and need to be redone. So we're going to watch this, and we're going to see what this tool actually does. So you see the tool is engaging the material sideways. And if we were to see it from the top, and we're going to look at just the flute, you see as it cuts, it's engaging a certain percentage of the diameter of the tool, and that percentage is always the same. That is what is defined by our optimal load. So you see in there, it's about 40% of the tool diameter that it's stepping over on every one of those tool paths. That is one of the huge things that makes a 2D adaptive or a 3D adaptive a smart tool path, and we call this high efficiency machining. We control that parameter in the passes tab under this optimal load. And I can edit a number in here directly, or I can right click, and we talked about before, you can edit expression. And here I'm doing math. I'm taking my tool diameter and I'm multiplying it by a percentage. Often in metal machining, we'll stick to around 10 to 15%. In router world, we're often at 40 or 60 or 75%. But that's, you'll learn more about that later. If I change it to 25% as opposed to 40%, you'll see those blue lines will be a lot closer together. Don't worry about that parameter too much for now. If you make that percentage bigger, it takes less time to generate your toolpaths, so that's a nifty tip for when you're doing all this crazy stuff. Okay, I'm gonna briefly run through a couple of the parameters that we edit frequently, and then we're gonna be done. The minimum cutting radius here, what we're saying is we're telling the tool, you can only, you should never come to a complete stop. Imagine we're cutting into a corner. If the tool comes into a corner, stops, and then moves on, that's bad. We want it to come in and do a small radius, an arc on the edge. You're gonna play with that parameter too, and that makes a big difference as to what your tool chatters like. You're gonna play with climb versus conventional milling. We've talked about that a little. Stock to leave and multiple depths are the same thing they've done before. Smoothing is the same thing it's done before. In linking, we get a little bit different. We have different retraction policies, which those you guys will just have to play with. There's no real way to explain exactly what they do. Lead-ins are the same, and the ramp controls that, that spiral that it does to get into these closed pockets. Okay, so those are the main parameters of the 2D adaptive toolpath. I'm gonna give you guys a lot of practice with different selection methods. We're gonna use the same part, and we're gonna look at a bunch of different things you can do with it.
I got a quick question.
Yeah, fire away.
So let's say like our lead in and lead outs are giving us trouble, like they're giving us an unwanted shape where we're trying to mill. If you ramp in, do you still need to lead in, or could you just like, you can just ramp right in there?
Correct. That's the purpose of a ramp. A ramped contour lets you avoid lead-ins. You still want to lead out probably, but you might not want one. For ramping into that closed pocket, that also avoids lead-ins and lead-outs. But with these tool paths, you still get lead-ins and lead-outs at the end of every single line. Everywhere it needs to retract and come back, or just stay low and backfeed, it's gonna lead out, which is important. And that's a parameter you'll play with. If your lead outs are huge and you're doing a ton of material, it's gonna take you twice as long. If you make them really tiny, you might crash. So there's a lot to play around with there. And once again, that's no amount of simulation is gonna teach you those things until you actually get on a machine. Just like these retractions here, that would take forever and a day, but you're not gonna see that in simulation.
Gotcha. And I've got one more question.
Yeah, fire away.
So like on that, toolpath that you have right there, if you were to like reduce the, I think it's called the cutover.
The step over?
Step over, yeah. So if you were to reduce the step over, would you be able to cut deeper, like before doing it, like have a bigger depth of cut?
Correct. That's part of the purpose. If I'm only cutting a 1/4 inch down, I might be able to do more of a step over. If I'm cutting 2 inches down, I'm gonna have a very tiny step over. What you think about is the bite you're taking of the material. You want the area of that bite to be about the same.
Okay,
That makes sense.
Awesome.
And once again, in the router world, we tend to go shallow and step over far, whereas in the VMC metal machining world, we tend to go deep and step over a little bit every time.
Okay, sweet.
Yep. All right, thanks guys. My computer is going to die in just a second. So feel free to Slack me any other questions you got. Thanks guys.
Thank you, Tyler.